Okay, so this is the BraneWaiv code, all built using the Arduino IDE. My board is in SparkFun ESP32-6 because it features Bluetooth and Wi-Fi connectivity amongst other things. And it's a fast processor, so it's not going to restrict the speed we can flash the LEDs and address them as. If you wanted to use a larger display with more LEDs, that's a benefit. A couple of things I've done to make life easier on this. Firstly, I set the CPU frequency to the max, 160 megahertz. And the second thing I've done, set the flash size to 4 megabits, and the upload speed I've set up to 921k. And it really does help the speed that it compiles at. The second thing I need to show you is remote.I. The remote.I is a development system online where you can develop projects that need cloud connectivity. So BraneWaiv, amongst other things that are on there, I will share the link in the article. Here's the app, which is exactly what I showed you before. So this shows the colour of the LEDs so that you don't need to look at it directly when you're setting it up. So then you can build controls. These are just labels. A label just allows you to put some text on here. So labels for that, you can do various other types of controls. The RGB indicators, that one at the top. And then the switches are push button, is a push button. Push switch, sorry, push on and then push off again. And it remembers the state of it. Whereas if you have a push button, it just presses it and it goes 1 and then it goes back to 0. This one, when you push it, will maintain its state. And you can program it what the caption is. So red for off and green for on. The first drop down is for the number of LEDs, and that's obviously dependent on how many you actually build it for yourself. But I did it with 25. And the waves, in inverted commas, they're wave patterns or programs. I've just put a little thing in to guide you as to which one is which in terms of frequency, and then you can refer to my document. And the power control returns a variable I call speed, and that goes from -100, I'm pointing but you can't see my hand, -100 to 0, +100, and then I've done a little calculation to scale it. When you've built your code or modified it, should you choose to do so, you can then go to get source code. And this page allows you to download the source code. There's a link to the remote.I library, which is available on the Arduino extensions anyway, not a problem. There's a long comment at the top about how it was built and how it's licensed. And then it goes through the code. So this defines the variables. I'm going to set up a Wi-Fi access point on the ESP32 called remote.I. But when you actually go into it, when you select it, the name of the program will come up because you could have multiple programs. And of course the program is called BraneWaiv. Set a password of 1234567 and this is not sensitive data. So I don't see a problem with it. You know, you can always recode it if you want to. I'm not sure what happens when multiple people are accessing this, I'll be honest. And then the configuration, this defines the position and controls and everything. There's a structure which then abstracts these classes and variables to make them accessible. So you don't call pattern selector, you call remote.I.pattern selector, and that will give you the value of it, and you can send things back as I send back the values of RGB for the LED. And there's another flag which changes to 1 when it's connected, which is brilliant. That's the end of the code. You then need to add in your setup, an initializer, and in your loop, the handler. It's that simple. You can also use a QR code to connect to it if you want to. That's your choice. So, in the Arduino, Obviously, I've downloaded the correct libraries for the board. I've set up the correct port. And at the first page is exactly what we just looked at. I won't go through it again. And then we get to the main program loop. So this is the code that we've copied from the RemoteXY site. And that's where it ends. Then my code starts here. So we need NeoPixel to drive the WS2812 display. That's what I've used. Yes, it's possible to use other ones. If you use a different type of LED, matrix or strip or whatever, feel free to use it. So I've defined some arrays to hold the name of the wave, that's just for clarity when you're working on it. The mode, I've just called it mode, and these are the frequencies for each mode. The 1000 just triggers it to say, put the light on constantly, I just want an ambient light. And then the colours for each are programmed in here, in RGB format, as you would expect. I'm sorry, obviously I've defined my pin for the display, which is pin 8, to send the data to, the number of pixels, and then the number of waves. So if you change the number of waves, you only need to change to one place. There's some additional ambient colours there if you choose to use them. And these are the patterns for the LEDs. So on level 1, there's only 1 on in the middle, then there's 5 on, then there's 9 on in a diamond shape. I don't know what shape that is, but it just puts the corner and middle ones on as well. And then the last one puts all 25 in. They have to go into this pattern so that we can scan through the LEDs and set them on or off. So according to which pattern you're on, it goes through all 25 LEDs very quickly, as you will see very shortly. And it will put the appropriate LED on, and then it will also put them on in the right colour. So again, variables for the pattern, the wave, the steps. Ignore the start time and current time, I didn't use it. These are unsigned integers because it uses less storage in memory. We then have to initialize our object, create an object to access the WS2812B or whatever you're using. We need the number of pixels, and the nice thing about the Arduino thing IDE now is it actually shows you what the variable's been set to. So the pin on pin 8, Neo GRB, the reason being the matrix I'm using is programmed in GRB format. Now because you've told it, you can program it in RGB. You don't need to do a conversion. And Neo kilohertz 800 sets the clock frequency, the data clock of the data to 800 kilohertz. That is the highest you can do on certainly on the board I used, on the LED matrix I used, and that seems to be pretty common that they only go up to 800 kilohertz. Quite often when it's been programmed with an Arduino, they only use 400. So that makes it run as fast as possible. So we initialize the RemoteXY, which will make the application work. Program the serial port, and I was testing it quite fast because I had some issues with it slowing down, which I then sorted. It actually turned out to be due to having more than 5 controls and being a non-paid subscriber of RemoteXY. So if you're willing to pay their fees, you can actually use more controls. And then we initialize the WS2812, clear the display, and yeah, I could have used that elsewhere by the by, and show. Only when you tell it to show does it actually do anything. So when you can program all 25 LEDs and then tell it to show, and they'll all come on simultaneously, which is pretty slick. Obviously, if you want to create snake effects and things, you do it a different. The main program loop, again, needs to talk to the RemoteXY handler. And now we can get the value of the pattern selector from 0 to 5, 6, because all these are 0 indexed. And the same with the wave selector. So although I say the 6 waves is 0 to 5, the frequency, the speed, as you can see, the frequency is being got from an array of integer numbers. I check the speeds within range. It always is, but it's just good best practice to do it. And then the frequency, I do a little calculation so that I can increment the base frequency or decrement it by 25%. And yeah, that took a little bit of working out. I actually used ChatGPT, but to get the range I wanted, maths is not my strongest subject. Now, the first thing we need to do is assess whether we're connected or not, because I don't want the lights to be on or doing something if we're not connected. So I tell them to flash, not at all. That's a bit of a misnomer, I know, I could just clear them. But that's the way I've done it. If we are on, if the delay is greater than 2 milliseconds, we flash the LEDs on the pattern that's selected, which it isn't yet. So this is just the first part of the loop. So yeah, we're going to, if the delay is longer than 2, so it is going to be a pulsing display, then call flash LEDs, and that does more later. It passes in the RGB values, the delay we want to use, the pattern we want to use, and the steps that we want to use. Now the steps I'll come back to in a minute. If you want to show an ambient colour, do that instead. So if we don't want to flash those, just send it to a solid colour. The ambient colour, so after you cycle through all the LEDs, show. The flash one, for doing all the pulsing effects, similar idea. I've set the RGB values. Now I've set them as float instead of integer, because when I do this calculation down here, it just rounds everything up and it doesn't really work in the calculation. So I've kept everything as floats, and then in the end I've converted them back to integers. It just works better when you're doing a division. And again, so the step I'll come back to in a minute. The idea is that if we just use a solid flash on and off, it's a really annoying thing to be watching. And yeah, it really would potentially cause epileptic effects on anybody who's prone. So I've tried to minimise that by making it fade in and out. Now I've tried to do it sinusoidally, nice and gentle waves like that. The maths was horrible, the functionality was horrible, it was consuming processing power, so I gave up. And I step it from 0 to 10, where 10 is the max. I then used that as a multiplier, multiply the maximum value 255 by the value and divide it by 10, that will step up and increase it. So 10 is maximum illumination, 0 is no illumination. And I do it for RG and B values. And I'll learn to program. So that is what actually sends it to the LEDs. That sends it. If the pattern is not, if the LED is not in this pattern, turn it off. That sends the program, the data to all 25 LEDs, and then show makes it actually display them, because it's buffered somewhere. So we now need to have a delay. I've simply called it D. What? There. So the delay needs to be 2 times the step count. The reason is because in that section, if it was 1 Hertz, I need to increment it for half a second and decrement it for half a second. But in that half a second, I need to work out a tenth of it. So 500 milliseconds, I need to divide it by 2 times the step count. I think that's right. And then that's the delay. And then we do the exact opposite. We start at 10 and decrement it down to 0. The code there is identical except that it's dividing everything down again. So that's the code. There's not much of it. It's a little bit convoluted, but it's really only from there down. That's from 86. Well, there is a bit, isn't there? 286. So yeah, there's 200 lines of code that I've written and 86 that are in remote.XY. Now have a play with the code. If you modify it, please credit me in it if you're going to distribute it. Ideally, upload it back to GitHub, please. I'll consider anything that's submitted, if you know how to, term is now, commit, and send it to me and put some notes in it as to what you've done and why. And I'll give it a test. I'll be quite interested to see if people collaborate on this. Please don't use it commercially. I may choose to do that later. So yeah, this is not for commercial use. But this provokes some thoughts. And even if it doesn't, you've got a cool disco lighting mixer. But yeah, hope you try the project. Let me know how you get on. Thanks for watching the video.